Well, let's just write it down and do like a rough after the talk.
So you don't want to spend all night.
Yeah, I don't want to keep you from the good stuff. So this is Philip Younger. He's from Münster in Germany. And I suppose he will tell you all the bits that you need to know. So over to you.
Thank you. Yeah, Philip is my name. I'm a software developer, like I suppose everyone, most of you are too. I work in a lot of different systems. It's usually connected to governmental stuff in some way, which has just happened to me over the last few years. I have no idea actually why this happened. And technology-wise, I'm more or less at home in .NET, which also happened to me, and I also don't know really why this happened, but I've been trying to change this for the last 2 years without success, but I'm still trying. During the projects I did during the last few years, there have been like one or two common things to all of the projects, and that is that the project actually were concerned with quite complex data, or data which changes a lot over time in terms of structure and how the data is interpreted and how the rules are formulated. And this led me, more or less not by accident, but by searching to discover 2 topics, which are the topics for this evening. One of them is called Event Sourcing. The other one goes by the famous or infamous acronym CQRS, Command Responsibility Segregation. I have no idea who you are, so what I would like to do is to start with a little show of hands to get an idea of who of you has ideas about these topics or who doesn't know these topics. So let's start with the acronym. Who has heard of CQRS in any way? I'm scared of doing the complete introduction. Who has done a system according to CQRS? Okay, that's good. What about event sourcing? Who has heard of event sourcing? That's great. Okay. And who has done or worked with event sourcing? Totally didn't. Okay. So yeah, that spares me. So what I'm going to do tonight is to show you a small demonstration. And Matthias somehow talked me into doing this in a more or less functional way. I'm still not sure whether I should thank him or not. But actually it was quite interesting preparing this. But the functional will be more or less concentrated on the event sourcing part because it lends itself very nicely to this. I will be doing a little bit of live demonstration. I have thought a long time about what language to use. I suppose you're, as I gather, more or less mixed up with all kinds of languages, which is a good thing, but it also makes it more difficult to decide. So I thought I'd go with Haskell because it's actually I tried to decide between F# because I know .NET and Clojure because I think Clojure is interesting, and I finally ended up doing F#, but it was like a split decision. I couldn't really decide. So who of you has done any kind of F#? Okay, so I'll probably go very slowly to the F# part so that you also get an idea of how the language works and get to the language. What I would really like to do is to get a discussion started in this sense. So, of course, I can just show you the stuff, but if you actually come up with questions in your head, you just ask them because there's a huge probability that the other half of the room is thinking about the same stuff and wants to ask the same questions. If you have any questions, just blurt them out, and maybe you can actually get some discussion going with this. Okay, I'll do a little bit of motivation on the event sourcing part, with which I'm going to start, but since you've all heard of this, it will be very, very brief and very limited. So the basic idea of event sourcing, I suppose you're all aware of this, is that you actually don't store state anymore in terms of like data structure, which changes over time, but instead you record events, which is synonymous as far as I'm concerned, over time, and whenever you need to interpret this history which has been recorded, you actually run what's usually called projection over the history and evaluate it in terms of whatever you are now concerned with. We will have an example system, and I'm just giving you the complete example because it's easier to think about the complete thing than the abstract thing. The example system I'll be working with will be like a simple order fulfillment system. So there will be a company with a stock on depot with goods, and the goods will be bought from suppliers and they will be delivered. We register that the goods are brought into our depot, and then there are customers who order the stuff, and it can be delivered to, or it actually just goes out of the depot and it happens afterwards. It's not anymore of our concern. And to give an example, we could have interest in what amount of, let's say, a good called cornflakes, whatever this is available in stock in our system. And we don't actually have these numbers anywhere in our system if we use event sourcing, because we just don't store the current state. We don't store, like, we have 10, how do you call them in English, pellets, I suppose, of cornflakes available anymore. What we instead do is we store the number of pellets which have entered our system from suppliers, or entered our depot from suppliers, and the number of pellets we have sold off to our customers. So it's essentially like if we have a history of these events, so this is going to be like time. Of course, I picked the one pen which doesn't work. Okay, there we go. So this is like time. And the first event we have is like goods arrived, and it's cornflakes. It's always going to be cornflakes. So I'm going to write this again, and it's like 50 pellets. And sometime later, we have a second event which said goods dispatched, and it's like 10 pellets goes. Now, obviously, the message we've got 40 pellets left in the system. And this is what the software is going to do all the time. So this is like the essence of event sourcing. The reasoning behind this is that if the data structure, like for example, talking about the number of pellets in the depot, is going to change a lot over the lifetime of our system, it's actually easier to store the events than to store state like in a database structure, because the structure of any of those events, like what it is, the topic and the additional data, in this case the kind of product and the amount, this will remain true forever. Because even if I completely change the way my system works, the fact that 50 pallets of cornflakes arrived on, and I should probably put a date on there, so it's like the 30th of July 2013, some time, this remains a fact forever. So whatever I do to my system, this will remain true. This keeps me from having to do like database schema changes over time. This is like the main motivation or the basic idea for event sourcing. The part of the software which does the math for us is commonly called projection. And this is most of the time probably not very difficult software, but it's actually quite interesting because in there lies a lot of logic, which is the interpretation of the history in terms of what we want to know today. So this is like one of two parts of the software which is critical, so to say. This need not be constant over time. Okay, the events remain constant because they just record in fact the projections. I can change at any time. I change the software, I change the projections, but the history remains constant. This is the basic. Now, to those who have worked with event sourcing at some time or have looked at demonstration projects, I mean, there are a lot of demo frameworks out there, might have felt that this is actually a little bit of, or this used to be a little bit of a difficult topic because those projections and a lot of demo software which is out there tends to be like spread out all over the software. It's like the logic of projection keeps on to be repeated. So just go to the context of CQRS for a moment. For example, you have like, in addition to queries going into the system, you just want to know how much goods are available to display to the user. You also have business rules which need to act on this number. And very often you have the projection logic duplicated in two places. This is something which I'm going to avoid today. This is actually like was the initial motivation. We had to talk about this like a few months ago for having this meeting. So the first thing we are going to do is we are going to create events, and we are going to do a little bit of projections on the event and try to do them in such a way that they actually we don't get any repetition. Sometimes it might be actually quite difficult. So, of course, we spend so much time with fridges. So, you still want to see this one?
Can you project this?
Also, went on a break. Okay, who here has experience with Microsoft Stack, which means with Visual Studio or .NET? Okay, about half of you. The common way of working in the world of Microsoft is a Microsoft Visual Studio, which is a common IDE for doing .NET stuff. And this is what we have up. It's a little bit small, but if there's source code, I will blow up the front side source. There's a little bit of stuff already there, but don't irritate because it's right now it's basically empty. I just put up some files. I get them there faster later. The first thing I'd like to do is to give you this. The exact example I just talked about on the whiteboard, so we're going to make ourselves a file which contains an event or two, and for the time being I'll just call it model because I have any better name for it. Right? In F# everything is contained in a module, and just a namespace. This is readable from everywhere, or should I make it loud? Okay, good. And in F# there are a number of data structures one can actually use for creating a thing like an event, because an event is basically just a data structure, just holds data. And the thing I'm going to use is what's called a record. It's close to a structure, or think of it as a class, which is really beautiful, so it's probably only. And we're going to make ourselves two events, and the first one will be called goods arrived at depot. And then we need to put some fields in there. And yeah, so what characterizes this? The first thing I need to know is what kind of product that will be. So I'll have some field called product, or it's probably rather going to be a product ID. And I need some type for it, because F# is a strongly typed language, so I need to put type annotations to at least the data structures. Later on they can be left out more or less. And I'll use a unique identifier, so it will be what's called system.unit in .NET. There is one thing about F# which is one needs to get used to, and that is correct indentation. Because it's really sensitive to correct indentation. Still always about it. Okay. So what else do we have? We have a product, and we have a quantity of stuff in this product, and this is probably going to be of type some integer type, integer 32. So this is like our first event. And the second event will be the opposite, so it will be like goods. Let's call it dispatched to customer. And it will be about the same. So I'm not worrying about type at the moment, I'm just trying to put whatever I'm going to So that's our model. That's already nearly done with the software. The second thing I would like to do is to do a projection. So to come up with a number of items in stock, for example. And maybe we can do a little bit of test-driven development. So I can start off with a test and then try to come up with a formulation for the test. So we may also have test below. So like projections. It's going to be a class. Class in F# looks like this. It's those are members of the type. And it gets a type annotation so that we actually know it's going to be a test. And in addition, we have to open some namespaces. It's like a using command in C# and other languages. Testing framework called NUnit I'm going to use just like in JUnit or XUnit. Okay, so what do we want to do with projections? The first thing we can do is we can make ourselves a history of events and come up with a test case that given goods arrived and goods were dispatched, then there should be like the difference still available in the depot. So we need a history. And in the history, we now put a little bit of data, so there should be one event of type. I'm going to copy it around a little bit so it doesn't take as long. Let's come up with some product ID. So we need an additional product ID. Let's call it product 1. And duplicate this, dispatch to customer, quantity missing, and the first one should be 50 to stay with my example, and the second one. Sure. Namespace missing because I put it in the module. Module is like essentially it's a static class, and I should qualify this by putting the namespace before this is bytes. So it tells me I made a static mistake. Okay, now
is there S on the last line? Quantity was static.
Yes, doesn't make any sense. And I can actually make this a little bit more concise.
Could remove the quotes from quality and quantity.
All right. I've got this. I could remove the underscore. But you're right. It doesn't hurt anyway. Go to special customer. This was supposed to work.
Comma between the two objects or something?
The comma between your lines.
Sorry, continue.
Comma between the two objects?
So in a second. Okay. The thing I want to do now is to make a projection from the process and see that the projection gives me the correct value. However, what I really want to do is I actually don't just want to write code into this projection. I want to do something else. What I want to do is, since I have this term of stocks in the depot, I would actually like to have a concept, a piece of my software, a part of my software which encapsulate this concept. So what I really want to do is to be able to do something like, I'm just writing a little bit of pseudo code right now. Some kind of concept, I'll just call it concept of goods in stock. Whatever this is, I'll just leave it open for the moment, and then be able to say that current value equals some projection of the concepts goods in stock evaluated against the current history. So I should probably turn out of all the annotations so it doesn't better if I just start writing pseudo code, but just ignore the all of the figures for a moment. This is what I want to get at in the first step. The idea would be that whatever this concept of rules and stock is, it's actually like defined once in the software, and whenever I need it, I can use it. I have no idea what it's going to look like right now, so I'll keep it open for the moment. Projection is going to be a method which does the work for me. So now I'm trying to solve my problem.
I think you need to add spaces to the brackets as well. And I'm not sure if you need to type the array because it's two distinct types of events, so maybe you should create a union.
Yes, you're right. That's the point. For the Tom's last point was right when F# is a little bit conscious about typecasting. There are no implicit typecasts. So despite all the fact that most of these events inherit from the object, which is on the base of the .NET hierarchy, it doesn't implicitly typecast. So for the time being, I'll change this in a few moments. I'll just put a typecast in the end and then the problem is done. Okay, now I have this to decide on, and I have to write a method which does this. And now the question is, what is a projection? A projection is something which is essentially goes by either the name of an aggregation, or there's a mathematical name of left fold, which Clem always uses, so I suppose everybody has heard of a left fold by now, which basically means the following. You start with some initial value, and then you just have a function which applies every event as a change on that initial value, and at the end you get to some final result.
Is there a difference between the left fold and the reduce?
You have an initial start.
Reduce takes the first two items and reduces them. Requires you to have the same time of all your items. Whereas on a left fold, you can start with some time, and whatever you apply is the second time. You need to have a function which takes two parameters, and they may be of different type. You can reduce them or not. As far as I know, correct me if I'm wrong. What's going to be the initial value? Well, the initial value is obviously going to be 0. If you talk about items in stock or some initialization, but we just start off with 0. And the change I can derive from both of the events. It's just the quantity, call it quantity. But in this case, in case of goods arrived, it's going to be plus the quantity. So I just write plus quantity. And in this case, it's actually going to be minus the quantity. And then I will have a function which has to fold over this, since this is just addition type. So I just add up all the stuff, and then I arrive at the final amount. And the interesting thing we can now do is we can, instead of just writing out the function and doing it, we can specify in terms of a declaration what this projection should be. Because this allows us to reuse the projection again and again later on, which will be very, very valuable. So what does the concept or projection look like? I'll also put it in a record for the time being, just to give it somewhere. And I'll put those two different steps, the initial value and the modification, in fields of the record. So there will be like an initial value, and the initial value will be of type 0. And there will be a step, and the step function will depend upon what it is. So basically, it will be a function which takes the current state, initially to 0, and then continues. It takes one of the events, and it gives me the current state after applying the changes of one event to the current state. Okay. Formulated this well enough. So there is like an initial value, and then we have what's called a step function. And the step function is basically this change. And the step function starts with initial value and runs over all of the changes to give you a final result. And since we have two different kinds of records, I actually need to choose which of those it is. Since I only have the types at the moment, I'll use the types for choosing. So the step will be a function, and the function will take 3 arguments. So I'll just write functions is now it's commonly called a lambda method, or an inline function, or an anonymous function in the special F# version of the syntax, which goes by the word of fun for function. Sharp is fun, we say. And it takes the current state. It takes an event and outputs the new state. And the way it does this is by checking what the event is. And for this, in F# commonly use pattern matching. For those who have learned this function languages, have probably seen matching quite some time. Essentially, as far as we are concerned, it's just an elaborate switch statements. So we look if the event is of type. I'll split and copy this in. Oops. Oh, apologies. If the event is of this type, then we say it's going to be like the current value plus, and I now need to get at this object. Since the event is of type object, I still need to pass this. And then I hopefully have available the quantity. And in the other case, I can reduce the quantity. This is all. I mean, this is very simple stuff, right? But it's I'm doing this slow that you can also like the brain gets adopted to the syntax of F# as the same. And just in case there are other events in the future, I will say that in every other case we just return the current and the state. Okay, now this record doesn't have a type yet because I didn't talk about the type, I just wrote it down, so I still need to give it a type. Let's say there is a type, and since this defines the projection, I'm going to call the type projection. It's going to be a record, and of course it has like the initial value, and it has a step function. And we now have to annotate the types a little bit, unfortunately. The initial value for the time being is an integer, and the step function for the time being is a function which takes an integer as a parameter, and it takes any kind of object as a parameter, and it returns an integer, which is basically the signature of the thing I wrote on that. So the way of writing this message signature is, I suppose, quite unusual to all who haven't seen any kind of language which relates to F#, which was by the name of the ML languages, because that's the first language. You just read it by the way that everything before the last arrow is parameters, and this is the return value. Okay, so it's first parameter is integer, second is an object, and the last will be an integer. There's a reason for this, but it doesn't. Okay. So so now we have our good stuff, and I'm back to finding my errors. One bracket too much. Now what's left is a function which actually applies the projection. Of course, it has parameters, and we probably should call this not projection but project, since it's going to do something, and I would like to have the name projection for the parameter, because the thing here is in fact the projection. And finally, I have some kind of history. And now the only thing I need to do is I need to start with the initial value, and then iterate through all the events and apply the projection function all the time. So what I'm going to do is I'm going to call a function from the F# library for lists called list.use. So this something funny about functional languages, which I also learned in preparing for tonight. Is if you're coming from like an object-oriented language, especially if you have a good IDE and work with Java, for example, or with C#, you're used to being able to just like dot, and then your IDE will tell you what is available. In functional languages, you don't have functions on objects. You just have libraries of functions, so you start to get used to having like groups of functions, for example, in the list module, and then you know that if you're working with a list, you start out by writing list dot, and you look whatever is there, and then find the current function. There should be a fold function, there is a fold function, that's good. Let's have a look at the signature. It's probably not readable from the spec anymore, so I read it out. So the fold function takes, the first thing is a function that modifies like the outbound step function, the value, then it takes the initial value, and it takes the initial value, takes the function, and then returns a value. So, with a bit of luck, this is exactly what we need to do. First one will be our projection. Dot step function. The second jump will be the initial value. And the final parameter is the list of items. And if I saw this correctly, the signature of this thing is different. So the idea is that this would work. And now let's see if our current value really has a correct value. Our history has like 50 items arrived in stock, 10 went out of stock. So you should be able to signature assert that the current value should equal 40, which is the way one writes assertions in F# unit. Okay. So, only thing I need to do is I need to put all of this in a test method. Forget to do this. Shouldn't be smiley, but somehow it's fitting. And if this compiles, it's a big if. Okay, let's see. And I've got documentation here. This is really funny. When I was in university and school, I always used to make fun of the teachers who sat in front of the blackboard and they wouldn't see the simplest mistakes. I can tell you it's normal. Okay. Again, that starts. And actually the test should run automatically because I have Endpunch installed, which you can't see because it's right here. It's in green. And it tells us that the test work if you go over there. Okay, so this is like the basic, very, very, very basic idea of event sourcing. Okay, we have the history, we have a concept. I'm now removing the word concept because you actually know it's, I'm calling it a concept. So what's this? And whenever you need to evaluate the current value of a concept, you run the projection. This is like the basic. Okay. I told you that I have a little bit larger system I want to work with, and what I would like to do now is to increase the pace a little bit, so I don't have to live code everything in this way because it will essentially be boring. Give you an idea of what system I want to aim at, and then show you the parts of the system which correspond to what I just did, and show it in a larger context. By the way, some already asked me, and I told them that if you want to look at the complete source code of the thing later on, I'll just put it on GitHub and I'll maybe just send a tweet out or give it to Matthias to post on pages. Okay, this is basically the specification of the system I talked about. The first part I already told you, the interesting part gets down here. We have some definitions. These are two definitions or three definitions. Two definitions I'm going to work with. The first one is a product in our stock is going to be called deliverable if it is in stock or it's being in stock, if it's inbound from the supplier. And the second thing is the product is called available if it is deliverable or it can be restocked. This will be important. There will be rules that the customer can order an item not only if it's in stock but also if it's there are some manufacturer requirements. This is the most important thing. Like from scratch in detail, completely tested in like remaining an hour approximately. But what I wanted to do for the project in general, which was like the basic idea, was to actually not use any kind of preconceived frameworks or libraries. Because what I want to do in this in the demonstration, in the project, is to like bring out the basic concepts as clearly as possible. Instead of relying on a library to do the thinking for me and forcing me to use whatever the library developer thought. So there will be, to finish this, in the final demonstration project, there are actually only two libraries. One is a web server, because I was not going to write my own server again. And the second one was just a testing framework. It's obvious. And there will be a little bit of HTML templating, but not in terms of the library. It's actually self-templated, especially for you.
Thank you.
Okay, so much for the setting. And the solution of the software will have the following parts. There will be, I'm just going to rearrange this because I have the other way out. I define some terms as business entity, which doesn't have anything to do with entities in like a technical sense. It just means that these four words have meaning in the context of our problem. There will be a supplier, I suppose it's self-explanatory. There are products. There is a purchase order, which is an order which we submit against our supplier in order to deliver this goods, and an order which our customers place against us. Okay, since this is a DDD meetup, you probably all know that this is quite a common situation in software. This is like a fundamental thing of domain-driven design to find out that there are actually terms in the software which can be overloaded in the terms of the business meaning. So we actually can talk about orders when we order something from the supplier. We talk about orders when we accept customer orders. They are definitely not the same thing. And then we have two options. The one is to change the wording, which basically means if we are talking about developing software in a context with some customer, I go to the customer and say, you have orders, it's not the same, you need to change the word. Usually that's hard. And the other way is we introduce what's known as bounded context in domain-driven design process. This we're not going to dive into today. No DDD beyond this point. So it stays with purchase order and order. And since this is a very common question, there will be a number series, which is like the consecutive order numbers. There are some constraints, but that's not really important. So let's see. Who reads the DDD CQRS news group on Google? Okay, not that much. It's worth reading, actually. It's quite interesting most of the time. Besides, like, seeing who is there, it's also quite up there. And from time to time, it's actually also quite entertaining. It's one of the best used groups I have been reading for some time.
These are people with DDD and PHP. It's from PHP.
Actually, there are at least two people doing DDD and PHP. I know it's not the same. Okay. The second part I've been doing is, actually this is like taken from other, the idea is taken from other projects, come up with the actual events. I'm not going to code them all by hand, but I just wanted to get an idea what's there. So there is some events related to what's called standing data, like the basic data, which doesn't really change too often. So there's like a supplier account has been opened with our company supplier, the account has been closed, the designation has changed. The same for a product. A new product is available from our company. This product is listed, designation has changed, product is deprecated. And on part of the supply, there is an event that one of the suppliers notifies us that a certain product is available in a certain quantity, or that it's not available anymore. It's called product delisting. And there comes the real meat. This event will denote that in the history we have submitted a purchase order to our supplier, to one supplier. This event means that the purchase order has been confirmed by the supplier or rejected by the supplier, and after delivery it's being fulfilled. With all of these events, there is some kind of metadata, like I did with the initial examples. Then we have events related to stocking of products. These are just the two events I started my example with. However, they are just a little bit more fleshed out. Not a lot, but not only product ID and quantity, but I also have like a purchase order ID and a record which supplier is actually I'm actually purchasing from. And dispatch to customer, there is an order ID, product quantity, and for good measure, a shipping address, but that should be sufficient. And finally, for the act of ordering, I can accept an order from my customer with a lot of additional information, like again the product quantity. And you may notice that my customer may only, within an order, have a single product with a given quantity, so it's not like a huge cart. I'm not into carts anymore. And the order has been fulfilled if it's has been. And there is one final event which solves the problem of handing out consecutive order numbers to our orders, which denotes that a new order number for the same is not allocated. Yeah, this is the setup or the setting of the thing. And I think I'm just going to jump to the other project and give you a hint of what's there. The projection I will justify together. This one, or rather the appropriate type, which is up here, was quite concrete. Right? This was only possible. This was only usable for projections which are of type integer in the end, and use integer as an integer value. For the real thing, this will be a little bit more difficult because my projection should actually be generic in the truest sense of the word, even as my software is concerned. Because I want to be able to define a projection which can deliver me anything. This is the first thing. The second constraint I'm going to lift, which is still in here, is that the initial value and the intermediate state in this example was the same as the output state, which here made sense, right? Because I'm putting in integers and I'm working with integers all the time and I'm delivering integer in the same thing. However, this is not really necessary in a technical sense or in a mathematical sense, but would actually be a better way to do it would be to make a distinction between whatever comes out of the projection, so that this type and this type are not necessarily covered. This allows us to keep what's usually called a hidden state along the projections. So you can actually, within the mathematical step functions, you can have additional data, you can memorize the stuff. And in the end you can say, okay, out of this memorized data package, I'm now extracting this thing which actually interests me, or which actually interests the caller of this function. So these are the two things I'm going to change. And as I said, I'm not going to live code all of this in order to make it a little bit slower, but this is what it looks like in the end. It's basically nearly the same thing we had earlier. So it's a type projection. It's now generic, like in generics. And we still have the initial, I called it initial value earlier, my mistake, which is now of some type called intermediate. It's a generic type, so it means it gets replaced at compile time with the true type of whatever we're looking at. The step function still takes any kind of event, takes the intermediate state and computes a new intermediate state. So it still runs from event to event. But we get an initial function, which is a final projection, which takes my initial state, my intermediate state at the end, and then extracts whatever I'm really interested in BP. I know this is probably a little bit difficult to grasp without an example, but I can make an extreme example of what one can do with it. I could, in principle, say that, let's go over here again, my step function, or the intermediate state, actually doesn't compute anything, it just collects all of those functions, the function calls, and then the final projection function actually executes. In that case, I would keep the complete history at intermediate state and do all the projections the last thing. wouldn't make much sense, but it gives maybe a little bit more idea of what the hidden state means. You can put anything in there which helps you to compute the value.
So that's
For example,
sorry.
Yeah.
And the step would be a very intensive step where you would benefit by grouping things together. That would be
for
a good
example, could be anything. For example, if you're actually not interested in like a concrete value which has a relation to concrete values, but for example, suppose you want to do some averaging. That's actually a good example. And we want to average the number of goods in each event. Doesn't make much sense business-wise, but just build it for the example. And maybe we want to average over months. So I'll change the date from 20. This is 30. And if I want to do an average, I need to count and keep the total number of things. So in this case, my hidden state would be like a dictionary or a hash map for the .NET people of months as a key, and the value would be items and stuff. And then I would run through the history, and as long as I'm within 1 month, I would add the stuff. So for 7 of 2013, I would say it's 50 on the first event, and then on the second event, it's -10, so it's 40 in the end. And then for the other months, I would have other values. And the final projection could then just be an averaging over the thing, and I would say on average, I've got 40 items installed in the last week. So this is like the basic idea of hidden state.
So people call this map reduce, or in secrets, select and group by.
It can actually be interesting to keep the actual events or some version of it in your private state, because then you can do stuff like looking back. If something happens or some event comes, you can look back and take some state from it.
Exactly. This is what I was hinting with the idea that you basically could keep the complete history and project it in there. So whatever information you need to process, you can keep in there and project it there. So this is what this does. Initial state is just a value. Step function takes a state from one step to the next based on the current object, and the final function does a final projection. In addition, there is a selector which is not too much importance right now. It will be of importance if we have if we want to analyze events filtered by certain criteria. For example, I want to run my projection, but only for products of type conflicts. But I'll say more about this later. Okay, the function I just named project in the earlier example. To make it a little bit smaller, unfortunately, F# tends to create long lines. So we can break here as well. Break it and see. Okay, that's good. And I can break here as well. And see too. Okay, this is basically my project function. It gets a little bit more complicated, but the structure is still the same. It does a fold over a function which is essentially the projection function. Made a stupid change. I need to change the arguments. That's not really of importance. Takes the initial value, and then whatever comes out of projecting over all the elements, I pass on into the final function, which then computes whatever I want to get out. You might be noticing that actually the history of events themselves don't appear here anymore. It's not as much interesting in the context of event sourcing, but in the context of function languages, because actually this whole thing is still a function, because the fold as last parameter still requires our history. And since I didn't give the history, whatever comes out here is a function which takes the history. So it's like carrying basically. Which is very nice, and I must say, before I worked with projections and event sourcing, I wasn't really able to value what functional programming can do in this respect, that you can actually write a function which omits the gritty details which you don't need to know. So it's actually history in play, and it gives you a function again which just where you just specified a bit of the computation. Okay, so this is the projection function. It's now called evaluate on demand because it does like on-demand implementation. Every time you call it, runs through all of the history. This is not going to be very efficient, obviously. And there is a second one. It's called on-demand filter because it actually takes a key. This is key and only respects a certain part of the history, only events from which this event is. But this is a detail. It's not too much of importance. Okay, so this was the abstract type, and of course we also have the concrete projections. I'll just skip over a little bit. Example. So this is basically the same example I did earlier. Okay, it's again the product items in stock, and we have the initial value. The selector just says only respect events of these types as a product that fits. So I can only project a certain kind of product. Step function is nearly exactly what I had earlier, except that I don't write current state and event goes to current state plus event or quantity anymore, but I just give a function which takes which just adds the quantity whatever I apply to, and then it's internally applied to the state. This is again recurring, basically, just reduces the number of keystrokes. And the final projection is essentially just a function which does not change the value, so it's like the identity function. Now, you may recall that there was actually a second definition I gave you when I showed you the specifications, and that was that an item is in stock, if it's in stock, of course, but it's available if it is in stock or being delivered. And now, of course, I can do a second thing like this to identify what does it mean if an item is being delivered. Hope it's not too far away. Since I'm not talking about delivery, but I'm talking about purchase order, it's called items in purchase, so I should use my own ubiquitous language, I don't forget it. This is very much similar to the earlier case, but I made a change there to demonstrate something else. This actually now keeps like a list of all the current orders, so it's not like a single value which gets built, it's like a dictionary or a hash map. So we start out with an empty hash map, and for every purchase order which is confirmed by suppliers, for every purchase order which becomes effective, we add some data. That's what the data looks like. It's not important. It's just the content of the events. So this is like again a concept, but this time the concept is not the state of like a single order or single product, but now it's like a global state, an overall state. And this is exactly the difference between the projection function which filters and the one which doesn't filter. And in the end, since I want to have the total number of items, I in the end just sum over all of the orders for this project. Okay, so basically this means I can have multiple orders with different suppliers for one product. I evaluate all of them, I keep them all separate from each other, and only in the end I sum over them to know that I'm buying contracts with company A and company B and company C, and the total number of contracts being delivered is the sum of all of this. So this is why it says sum. Okay, now we have those two kinds of projections. Now my initial definition said that an item is available if it is either in stock or in purchase. Now, of course, I could make a third projection, which would tell me that I would have to put in all the events from the above case here too. I would have to keep two different states, and in the end, I would add this value to the value of item in stock. But then I would repeat the projection, and this is exactly what I want to avoid, because all know repetition is not the root of all evil, but it's evil itself. So I don't want to repeat ourselves at all. So what else can we do? Well, if you think about it for a moment, we actually, at this point, we don't really execute this logic. Right? This is just a declaration. And in principle, it would be possible to encode in what I just said, just to not put the additional events in here, but to set it aside in on the other hand, to combine them together, combine the two projections together, and only in the final projection step you would actually do this summation of those. And this is what this is going to get at. I'm just going to show you for a moment the result. Some space in here. I'm going to somehow introduce line breaks so this becomes readable. Okay. I used this already one time, and there was the resolution was a lot smaller, but it was still readable. But it will work this way. Okay. So what I actually would like to be able to do is something like this. I would be able to say the concept of products, items available, the total number of items available, is combined of three other concepts. So I'm going to add definitions together and say those are going to be evaluated separately, and then in the final step it's going to be available means in stock plus purchased minus allocated. And then I'm basically done with it. So what this gives me is that I have completely removed the notion of how I'm going to evaluate the individual projections, but I'm instead saying I've got a combination of the projections, and I have a rule for the combination, which is hopefully exactly what is written in my specification. And this is basically what event sourcing allows you to do, where you can get this event sourcing, since the concepts can be developed independently of each other, and if you have rules for like combined stuff, you can actually write a new projection or a new concept being the result of all of this. Is there some way to put some padding here? So I don't know about you, but if you're feeling the same as I'm feeling, I'm getting very dizzy.
You need a drink? You need a drink? You need a drink?
No. So
Maybe in that one as well.
I have a question. Why do you use the type structure of a projection and not just compose the function on itself?
basically because I want to be able to print it out very clearly to be readable. So this is maybe I should have said this. So the structure of the code is basically to be able to demonstrate it. Okay, so nothing of this is optimized for production, not at all. So actually, I've also only implemented like the on-demand projection there, whereas in reality would be quite different. So this is like optimized for short. So it's like named and you can read. Now, let's see. Okay, as far as event sourcing is concerned, this is actually more or less the end of it, at least as far as the principle is concerned. So this idea, detracted myself in case the combined function is of interest. It's actually quite simple because it does just what I said earlier. It says that the combined initialization is just a tuple of the three initialization values. The combined forget about the selector, the combined step function is just a function which takes a tuple of the three previous states, or the three intermediate states, and then applies the three different step functions to the three parts of the state. And the final step is applies the final projection of all three different concepts separately, and only in the last step the combinator is executed, which is basically this function down here. So it's really like having all three things in separate and then combining them and putting them together. Yeah, as I was saying, as far as event sourcing is concerned, this is basically it. as far as the, or as far as projections of events are concerned, is basically the concepts we defined there is the, say, it's a bridge from the business language, from the specifications into the implementation. And we can now use these projections in different cases. And this leads us now to the second part, which is the CQRS part. This is where we actually get something to show, because right now it's just mathematics up on the screen. So I want to use this now, and I want to use it in a real system, a small real system. So what I'm going to do with this is I'm going to put the system, or I'm going to make a software system which uses an event history as data storage. And it will have two parts. One will be responsible for executing business rules, and the second part will be responsible for delivering data, which is just a basic CQRS definition. So we have like the history up here. And we will have one part of the system which will have some kinds of business rules, and the second part which essentially contains only projections. I'm not going to write projections down here. For the time being, I'll stay with the term reported, which has been used in CQRS quite often. And the interesting part here is now that the projections we defined up there, they can be used in both pieces. For the reason that I will be using this to generate data to be displayed in some kind of user interface. And on the other hand, from the user interface, there will be a request to the system, which will be evaluated against the current state as defined by the previous history, and the result of the rules will be new events. This is like the basic idea of combining CQRS with event sourcing, which I suppose you know. What I now want to do, or what I can actually already do, is I want to be able to use the projections I have defined, both in the business rules, let's put some rather up here, as well as over here, so that these are actually the same. Because when I define a concept such as what is the current number of items available for a given product, the meaning of this term, the meaning of this concept is always the same, no matter whether I apply it or I use it in business rule, or whether I use it in a projection. So let's have a look at this. And I think we're just going slowly through the code. Let's maybe I can show you the project from the part of the user interface, from the web server starting, because it's on GitHub anyway, so you can also, if you're interested, go through it. From let's start with the request part, and I will look at a very specific part at the most interest. Let's say with the placement of I'll just show you the user interface to get started, which is highly complicated. Makes it a little bit larger. So we have the super developer art website, which does have a very nice function. It just prints on the starting page the complete history, so you can always see if something changes. And then it has basically two, I wouldn't call it, it's not bounded context really, but it's two areas. One of them is going to be the everything connected to buying products and selling products, and the second one is going to be everything connected to the fulfillment process or managing our data. I'll just show you one round trip and real, and then later in code. So we start with the product list, and we just have a look at conflicts, talking about conflicts on the events. Keep there. And the detailed page shows you a few projections with their current values with regard to the product conflicts. That is the number of items in stock, which is 0. The number of items available, this is 250, and some additional things I'm not going to go into detail. If you have a look at why it's 250 items available and in stock, we can have a look at our event history and see that, unfortunately, with the IDs, I can't tell you which is complex right now, but
85 euros.
Exactly, that's the other way right. But what we can see is that there are actually 2 purchase orders confirmed by the supplier. One of them is for cornflakes, I'm not sure which one it is, and one of them was actually received in the depot. It was not cornflakes. So the quantity shipped from the supplier was always 250. Cornflakes did not yet arrive. So this is the one. And if you look at the second product, we have Crispies. Okay, this is the one which was already delivered. There we have 250 in stock and 250 available because we have 250 in stock. So maybe let's first look at what happens if we actually get delivered those 250 items. So we can go to the depot management and suppose the truck arrives on scene and we get delivered 250 pallets of cornflakes. And now as depot manager, I can issue a simple command which says, I register 250 pallets of cornflakes being received. I confirm this, there's nothing to enter there. And if we return, we now have the items in stock. If we go back to our homepage, we see that on top a new event, or 2 new events have been added. First is goods received in depot. This is cornflakes. I now know that FAF is cornflakes. 250 items, and also the supplier fulfilled purchase. So this is basically the thing we're now going to trace in code. For getting started. Let's close the code. Single. Every one of you sometimes probably has written some kind of web application, so I suppose the terms are well known. I've been using a web server which is called Suave. It's an F# web server, but it's not really of importance how it works. The interesting thing to see is that it has a declarative configuration for GET requests, for POST requests, and the thing we have been using is the logistics goods received POST request. And from there, it just calls a function, which is called goods received from handler. And starting from here, you can walk. So what this basically does, like in every web controller, is it just takes all of the form data which is connected to this, and then, this is now different from many web servers, it doesn't call a function, but first it just creates a command object. Because what we are going to do is what we're now doing is we're passing the request into our rules engine to register that a certain amount of goods have arrived. Oops. This is really so killing me. Hope not really. Okay. Command is then being passed into the rules engine, and I'm then not going into the details of this, but I'm just jumping into the point where the command is being handled. Eventually, in any kind of system which handles different commands, we'll have to have some kind of switch, which, depending on what kind of command is issued, executes the different logic. And this is what we have on screen right here. What it does is again, it checks the type of the command. And in this case, we have the arrival of good. The parameters are requested, and then here comes the interesting part. The business logic in this case only consists of writing, for the first thing, only consists of writing the events that goods have been received with the appropriate parameters. This is the first event we have seen, but this is not really a lot of logic. There is a second thing. And the second thing is to remember that with every delivery there is a purchase order connected. So that purchase order, which is implemented as a class, which we will see in a second, is just created as an object, and it's being informed that the data has been built up. And in there we have the real business logic, and then you finally get a bit of event sourcing. Okay? What is not of interest. So what it does now, it has a guard function, and if the guard function succeeds, it's going to create events that the supplier fulfilled its purchase order. What I'm going to get is, and it's a guard function, because this now actually uses state. Because the guard function is to check that the purchase order is really in the state confirmed, so that it then can be fulfilled, as opposed to it would be rejected and it cannot be fulfilled. Now the interesting thing is, how do we get the state? Because this is now again a projection. This is one of the concepts of our system. And the way it is done in this demonstration project is, there it is that we actually execute one of our projections for the currency. If we go in here, then we are back at one of the projections, in this case the one which calculates the state of the purchase order. Okay, so the details are not really of importance. What's of importance is that it's the same code executed either here or here, whether I look at the data or whether I wanted to execute the codes. And then we actually are really complete with event sourcing, because it means that we have some history of events up here, and wherever in our system we need to access the state, we can project the history of events locally and evaluate it to fulfill whatever needs we have. So in terms of either producing data or in terms of evaluating views.
But if you're using the read model on the left, then you're not doing CQRS.
Well, that's the point of it is, it's
By
not,
definition.
yeah, it's not exactly the read model, right? It's just one concept.
Just a projection.
It's just a
Logic.
projection. I mean, you have a point. It's for sure. But the question is whether the meaning of the individual words of the business domain should change between that part and that part. And I think they shouldn't. So it may, I've had a lot of discussions about this, so I'm very to this point, or how to say. So the basic point is, or the original idea in CQRS was not to use the same kind of model as far as the non-functional non-functional properties with respect to data transport.
Yeah, you need different properties in your domain model than you need in your view models. For example, a name you don't need in your view model, ID you don't need in.
And this actually translates to this case in terms of the projector being used. Okay, so this should signify only the projection logic, so that is what is on screen. Actually, there's a little bit more to it. There is the real projection function. And there you have the difference between this. Because in this case, this would probably be the on-demand version, okay, which means that whenever I need, in the context of a business rule, need to evaluate the current state, I take the history or take the current state and evaluate it now, which is just makes sense due to the fact that we very rarely usually have evaluation of business rules. Whereas on the other hand, on this part, you probably don't want to use on demand, but what you really want to do is some combination of probably lazy and caching instead of on demand, so that you're actually able to pre-compute the data. And this now is really, again, the idea of CQRS. So what not propose, but I do in that case, is to actually separate the projection logic and the projection mechanism, or the definition of the projection, and the mechanism by which the projection is executed into two parts. So you can reuse the definition of the concept, or whatever it means, in both cases. So you're right that it's the same model being used in terms of business model, of language model, in terms of ubiquitous language, but the technical model is completely separate in most cases.
How would you do this in an object-oriented language? Instead of in a functional language, I see how you can reuse it easily, but how should you do it in an object?
Actually, it's just the same.
Because
It doesn't make a difference, because as long as you can at least have the concept of a function, as you have like functions as first-class objects, you can keep a function pointer and pass a function pointer. And so if you can create a structure like this, where you have functions as values, then you will be able to do the same thing. So this is possible in C#, it's possible in Java 8. It's possible in PHP. It's possible in PHP. I've heard. So this doesn't really make this a difference. Of course, the concept itself is of evaluating function, passing functions around comes from functional languages, it's true. But it's so powerful.
The concept belongs to a domain object, and the domain objects are not copied in the read model and the write model. They are two separate objects.
Well, this is not connected to the instance of an object. Right? This is just a declaration. And the is
it takes into account objects, and so the objects are one of the two models, I suppose.
So the objects are?
These are functions that do something with objects, but that object you put in is one of the two models. It's the read model, the write model does. Yeah, you have the read and write, so it are two different models. So which one do you take?
I think the confusion is perhaps, so all your events would be objects, and you would pass them around. The events are shared between the read and write models. You would pass them around. I think the original idea is here that we're not sharing the projector as a thing on its own, but we are sharing very small units of interpretation of events. So that's the only thing that is shared in the model, and it could even be that lots of them are not shared at all. That's
it's very likely.
Very likely that concepts only exist in one side or only exist in another. But when they are shared, like stock is something that could be in both, and you can share the concept of calculating stock, and that could be an object. You would have an object that is probably called
items in stock, for example.
Yeah, items in stock.
But it's not the real number of items of anything in stock. It's just the definition of what does items in stock mean. Okay,
So you could call it items in stock calculator or something, and that would be the object that you use.
Is your question about what you will do without event sourcing? Isn't it? Just use CQRS and no event sourcing.
I wasn't aware enough that it's about events, of course, and the events are shared.
No, you can do CQRS without events as well.
Yes.
Yeah, but then
I think you are getting at the same point Tom was getting before, right? So this is really something to, which to me took a couple of years to come and to be able to separate the logic of the projection and the method or the algorithm by which the projection is executed. Because it really, I mean, it's, I really have this problem, or I had this problem in a huge complex system that the projection was executed twice in two different states and two versions. This is a detour, but I think it's a good detour because if you look at the common example projects for CQRS and Event Sourcing, what you will usually find is you will find projections in the read model which just iterate through events, and then they actually usually iterate on demand. That is whenever, I'm sorry, not on demand, they iterate
when the event arrives.
Whenever the event arrives, right? So you subscribe to some kind of event store, and whenever the event arrives, the read model gets updated immediately. So if you query it, the data is already there, which makes sense because you want to have a fast response. On the other hand, in the rules, what people usually do is they, and this is due to the way Greg introduced this some time ago, is that you have a lot of apply methods. The apply methods take some kind of event, and then you have state, and the apply methods modifies the state. And in addition, you publish some sort of events, and the idea is that when you publish an event, it should also go to the apply method so you can vary your state. And what happens is that you now actually have the projection sometimes in completely different formulations and completely different algorithms in two places.
You're saying apply should then be handled? So
Whatever, yeah.
and evaluate the state, and then you apply it and apply it onto the event.
Yeah. So this is what I think most started out when we did event sourcing in the Greg Young way of doing things, the original way.
The on-demand would probably be cheaper because you're not calculating values when you don't need them.
Yeah, that's true, but I mean, it doesn't really matter, right? If it's cheap or not on that part, it doesn't matter. What matters?
It's a huge amount of events.
So why do you have an on-demand version?
Well, for the site.
But I mean, you could also have a pre-calculated.
Oh yes, yeah, sure. The point is just that, as far as I'm concerned, the on-demand version is the natural way of doing things, and everything else is optimization. And I would only take the optimization if there is a reason for it, so if I know that I need it. And if we talk about how large one source of events, one entity or aggregate, depending on how we talk about our software is, you should rarely have projections on this part of the world which run above a couple of thousand events. And a couple of thousand events, especially if they're already in memory, can be like on the order of microseconds pre-projected. So you don't have to worry really about doing anything else than on-demand project. If you do, then maybe the model is the aggregates are just not designed well enough. So it's a common example which I've also had myself is if we are talking, for example, about an accounting system. And you have an account here, and an account over a couple of years collects millions of events because you have millions of transactions over years. And you find it's not bounded, because you find that your account is not bounded, you need to do something instead of on demand. And the problem is actually, then I would actually solve this in a different way. I would change the way this entity or aggregate account is defined by not having it open in time, but by having it bounded. For example, you would have an account per year aggregate. And after the closing of a fiscal year, you will have a new aggregate, which is then evaluated differently, which is, by the way any kind of accounting software is implemented. They always have like closing of the fiscal year, and then they take like some aggregate data, and then they start out fresh with a new database table or database queue or whatever. So I think that one rarely needs to do anything else but on demand. What's of importance to me is that in this model, the projection appears twice in two different formulations. And I've been bitten more than once by changes in the logic, and I changed it in one place but not in the other.
But so what you're saying is that you try to keep the logic how to create a projection the same. So basically, that the stuff that you use to evaluate your rules upon is the same as the real views. And by using it the same, there's never a problem that if the logic is a little bit different, that you didn't update parts of the code, that there's a divergence between those two. That's a problem that happens.
Yeah, exactly that. So,
All the interruptions.
but no, that's the point of it. I mean, the idea of the basic idea of the project is to get discussions started. Right? Essentially, I'm trying to sell this kind of ideas because they have helped me a lot. And since when everyone said initially that event sourcing is known and CQRS known, which is a good thing, I think it makes more sense to talk about details of that level.
There's one disadvantage if you use the same things. The big advantage you have is you can, on the readable side, you can usually disconnect it and do it later on. You have the thickness, eventual consistency, and if you don't want to have eventual consistency in your and you're processing the rules.
It's going to be fun. No, that's of course true. Yeah, what might be of interest, because especially if since most of you haven't implemented a system like this, is the way that the actual events are made available or can be made available to like an aggregate or to a business flow. And thinking if I should show it or live code it. There are different patterns of doing this thing, and I'm just going to demonstrate. It's really actually a trivial thing, but it's I've in many systems seen this. And since it's made in a non-optimal or in a bad way. If I now try to take some space, if I try to let me see. No, I should show it the same system. I'm going back again to the place where I've been just before, where the rule was evaluated, which was not here. Right, which was here. So this is now again a class from the left side, from the rules part of the word, where rules or where commands are handled. In this case, it's everything connected to the purchase order, and the thing we looked at a second before was the function where the delivery was confirmed. And one thing which is like a requirement, which I should be able to implement, is that if I call this variable of state multiple times, during one execution of a command, it should always be up to date. Okay, this means if I change the state by calling supply fulfill purchase order, I should now be able to, in the next line, copy the guard clause, put it down here, and now check, let's forget the text for a moment, and now check that the state is now actually no longer confirmed, but it is closed. Okay, so that I can evaluate the concept within one transaction, even before this is all committed to the event store, and get changing values. This is especially interesting if one talks about functional problems with respect to event sourcing, because very often we've had the discussion in the EDD CQRS news groups initially that one could think about a command handler, like a function like this, being a function taking original state, then applying a command and putting up or resulting in new events which are being created as a result. However, this doesn't really work in reality, because during this function you would need to have changing state very often in order to fulfill logic like this, right? Because it just says that it's guard, it should be confirmed initially, then I set it to close, or I publish the event supply fulfill purchase order, and then I need to check that it's closed. And it will still be the old value because I'm still working with the original events I have to follow. And this is the reason why I actually don't do functional domain models anymore on that partner side, because I still need some additional state in between, which is now, in this case, represented in this little acronym in front, UOV or UOW, which means unit of work. It's just essentially like a placeholder for the current transaction. And the job of this object is to collect all the events being produced during the execution of a single command, but also to provide the complete object with the always current data. So what's really happening in there is the following. This is actually wrong what I showed you. The rules engine doesn't, or the object, the domain model, doesn't always get the current history on demand, but it's actually a little bit more complicated. There is really a little buffer with state in there, which is it's can be either called a transaction or a unit of work. And what it does is it gets the events from the event store, but it also keeps like a small list of all events which have been created during the execution of the single command, and then concatenates them both together. And whenever I need the current state in here, I actually get the history plus whatever I changed. And when I commit the transaction, I can actually just append whatever in there to the event store. So this is like the common pattern to use. And this is actually quite difficult to do functionally because it would mean you have this intermediate state which you would need to carry from line to line. If you do this functionally, it means you have to somehow have an array of events to which you continuously append.
Should use an IO model.
Yeah, but basically this is an IO model, right?
Now you're muting state.
Pardon?
Now you're muting state, mutating state.
Well,
So-
technically, if you have an IO method, you're also mutating state. You're just doing it in a functional way. I mean, that's the whole point of the IO method, just to locally keep the state and to not let it escape to the outside.
Yes.
Right? And this is essentially what the unit of work does. It keeps local state and it does not let it escape to the outside until you're finished. So it's actually, I think it is the same.
We should discuss how.
So this is a command handler that doesn't use aggregates in the Greg Young way.
Well, what's a great language of aggregates? I think he's changed his definition multiple times, but not in the terms of consistency boundary. Okay, so this by initially said there's enough of DDD, so in there's no aggregates in terms of consistency boundaries, it's just events and state being projected, because I was basically going to talk about event sourcing and not as much about domain design. Which of course is, especially if you go down this road, is an interesting question of how you can find the algorithm. This is essentially a question from earlier today.
But I mean, an aggregate would be in your setup just a projection, right? Or you could define a projection, which is like the real projection.
Yes, but
the true one, and that would be called an aggregate.
An aggregate would use the projection to decide which events to emit. I believe.
So okay, so it's part of the aggregate is a projection plus the rules and some of the rules logic.
Yeah, so the problem with the defining of the aggregate is that the whole point of the aggregate is that you draw a boundary and say whatever is affected by insight should not be at the same time be affected by things which change from the outside. Okay, that's the idea of consistency boundary. So it's like a transaction basically, right? You have some set of states, some set of data, and you guarantee that while you execute, it doesn't change without you being the cause of the change. That's basically the idea. And if you look at the projections with the different events being used in there, the idea is actually quite compelling to say there are a number of events in there, and they might somehow belong to, or they might define a consistency boundary. However, you are likely to have different projections which use different intersecting sets of events. So what one could possibly do is to analyze in one command handler which state or which events basically are being used to define the state used in the command handler, and then define this set of events as one aggregate, and define that no other part of the software may commit the same kind of event with the same IDs at the same time. I don't know. This is actually one of the because this is basically the question posed earlier today. It's really difficult problem, so there's no easy way of defining this. The common way to do it would be to define an aggregate by looking at the IDs which are part of the events being touched.
So one of the approaches that Rinat has been taking is he builds a separate aggregate state object and then he just applies a function with the channels comments and takes the aggregate state as a parameter. So it's more of a functional approach.
But it's still it's like a classical aggregate. What do you mean? It's like a
He has a separate
inside
state. Yeah, he
object.
uses a separate read model for its aggregate state.
Yeah, well, this is not too much different from this approach.
I think this is the same but more granular. Because instead of saying one big aggregate state, you have small individual states.
And then you compose them.
Let's see if I find a little bit more.
Often you wouldn't even need to compose them because often you only need one or two for a specific business rule. You don't need the whole aggregate state, you only need a few values.
I mean, in a way, this was probably an aggregate, so I think Gary was using the term. I think it goes really in the same way. There's now a customer order, and the customer order has the projection, up here the projections it uses inside, which is like information, it's just static data. It has the state of the order in terms of open, closed, fulfilled, partially fulfilled, etc. It has a concept called remaining quantity, which is just what is remaining of the order not yet delivered. And okay, this is really just the idea of the product being ordered, that's a concept. And I think the combination of all those, if you evaluate them at one fixed point in time, is basically Riyad's initial state of it.
That's the advantage of doing functional, it's lazy, so you don't have any overhead if you don't.
Yeah. But actually, I think that it's not really that much different. Even if you think about it, what the compiler does, I mean, there are functions up here. But since they are anonymous functions, what the compiler internally does, it creates objects for them.
Yeah.
So I think if the compiler would be good enough as optimizing, you can probably do it functional and you can do it object-oriented and compile into the same thing in the end, at least in respect to this. Yeah, so if you want, maybe this is an aggregate, but I'm an opposite term aggregate right now. So I call this, best I would call this an entity. And if we talk about what this represents, then it's actually what the best answer was what Yves said some time ago. Where is he anyway? In the back. Yeah. As I said, if you look at the different entities, you at some point find out that actually you end up with your processes, or the things which live over time, not in terms of real entities, but of working processes, or sets of rules which belong together, being the entities of the system. And this is very often I find this is like hidden by the language we use. So we call something order, and when we call something order, we think of the one-time order form, but actually it's the order fulfillment process. It would probably be a better name. At least this is what I feel with regard to this. Okay. So this is for the left side, for the command side. And yeah, actually there is not much more to show. There is a unit of word left. I can show it. Basically does what I said earlier. That's where I left off. It's really a very trivial thing. In this case, it's an object again, because it's basically, it encapsulates states for some period of time, so it feels right to make it an object. And in its constructor, it just takes the history as given from the event store. And for every event which I have called stage during execution, I just put it on a list called stage, or just an internal list in the unit of work. And then if I call the events, I just take the original history and concatenate to it the events which have been created during the transaction. And finally, the commit message, it essentially only returns the staged events, and whoever is calling from the outside is responsible to the event store. So this is really a very trivial concept. This is a transaction, right? So everything which is related to the web transaction is just covered in these few lines of code.
I don't understand what the use case is. Because, I mean, ideally, you would just publish the events in the history, but you're afraid that maybe there was a failure, and by publishing it, it already happened. So you take the history and you replay those events which are relevant so that your projection can update. And this is not the real view, but it's like the most up-to-date with those staged events. and then you see if everything is okay, you do the check, and then you know it's okay, and that's when you publish it to the history so that the normal models can update too.
Yeah, exactly.
Okay.
That's basically the explanation. But the nice thing about this, especially in languages which are garbage collected, is that you don't really have to worry about rollback. Because during one transaction, I just publish in this local list. In here, this staged sync, this is a local list. And if for some reason this fails, the current transaction fails, I just cut my reference to this thing and the garbage collector doesn't roll back. This is really nice.
One thing that you can do, because your comment handlers should always be void, they should return nothing, is I just return events, an array of events. That's one way to do it.
Yeah, could be, but I've in reality, on more than one occasion, also this might initiate some discussion, had transactions which actually incorporated a lot of events. So very often, at least in the real world, I found that a transaction can encompass several hundred or thousands of commands. So especially if have a software system which is related to like changing planning shifts for people, time shifts, then the commands there are actually quite granular. So it's like an employee is assigned to a certain role for a certain time slot. And if you do such a plan, you will have a lot of commands which influence single employees and single positions. But they, sorry? No, commands. I actually meant commands.
You group commands together.
Because essentially they're grouped together, because the whole thing would be way too complex to give it an individual name in each case, because there are like millions of possible combinations in which you can change the shifts, and they are sometimes even put together by the user. So the user defines how changes from one shift plan to the next version, how they should affect the single process. But still, we need to execute all of this transactionally, because if there is in one single position of failure, you cannot change all of the shift plans at all.
The alternative would be a two-phase commit. Just implement it yourself.
Yeah, but I mean, sure, but I mean, it's the same thing, right? Essentially, I actually tried in the business rules, and if it works, you commit it. If it doesn't work, you don't commit it. So it amounts to the same thing. And I've really had a hard time to come up with commands to cover the individual cases, because there would be just a command which says execute change, which doesn't really is a good way. And then I would have like a prepared list of change, which would then be read in by the execute change and execute. But basically, they're all just individual commands, because at any time the user in such a system can also just do a single operation manually and not have like a complete change. So this is why in my case transactions can encompass a lot of commands. Potentially. They don't have to, but they can. But I mean, this is obviously a point which is heavily discussed at times. Okay, so that was the unit of work component. And this one is actually, I need to say this is really boring. Because in this system, since it's not optimized in any way, I have to show this. It's probably the easiest code at all. Just remember where this is. It's not here. I didn't put a lot of work in it. It's not organized in any way. This is basically the lead model box in the system, and essentially it's just in here you find all of the single concepts which are defined in the system, and from the outside side you can just call them. And the only thing which is different from calling the individual concept or value to the individual concept from the outside is that in the constructor of this, which is called once per value request, actually there is a connection to the event store provided, so that from the outside I don't have to know that there is such a thing as an event store. So basically it's configured into the lead model. But then I just call all those things like remaining quantity in order, and the only thing it does, it takes the current events from the event store and calculates the projection available quantity in error for me, etc. That's slim. There's nothing else. Obviously, you can, in reality, you would put a little bit more of thought into it, but that would be only like checking security constraints, stuff like this. So nothing really connected to postcard set. As long as it's not driving away, it's not. But on the other hand, I mean, this is like the basic promise of CQRS. And the basic promise was that you can take all of the complexity which is in the system and keep it away from the data providing. And the only thing which I would change in a real system, in a production system, which is wrong in this approach, is that everything is created on demand, obviously, because it doesn't make any sense. Especially if you're talking about lists of statistical data, it really makes sense to pre-compute some of those. Yeah, that's basically the full circle of the system. I didn't show any of the web server part and how this is done because I just wanted to show the one time the full circle, starting from the projection itself, because for me this is the point where the most complexity lies, getting the concepts right and analyzing what kind of projections you can do from the events and what makes sense business-wise. And of course the second part is getting the business rules right. Everything else is separate. And I try to organize this project. I realize that you only like have a very coarse view of this now in such a way that the individual components of the individual ideas of event sourcing are localized very strongly. So that there is the projection is in fact a type called projection, and that's all there is to it. And the different executors of the projection, which only one is implemented to make this easier at this time, is just essentially a function. It's just a single function which does all the same thing, but you can write a second function which has completely different runtime behavior to replace it if you need different runtime characteristics. But it doesn't affect any of the business part of the behavior. It just affects the runtime characteristic. And the same for the remaining part that it's, in a simple system, those things are necessarily quite trivial.
But that's not how you do it in production.
Well,
I mean, have you used like functional
basically, this is actually the second time I've done something in F#. So it's like I'm not using function languages in production, but actually this is distilled from the way my object-oriented systems work, because over the last 3 years, I think 2 years, my object-oriented programming has become quite functional, I have to say. So what I tried to do in this project, which was the motivation of doing this, was to distill from the real systems those things where I think there is a concept which makes sense to be put in a single place, or to be like highlighted. Okay, so the basic idea of this, and why I'm trying, or what I'm trying to transport, is that the individual concept of event sourcing and CQRS are very simple. You can actually put them in like 3 or 4 lines of code, and that's all there is to it. There is no need to invoke huge amounts of framework. For example, if we go once more to the projection function, which was here. This module of this file is called event sourcing because this is basically all there is to event sourcing, so at least event projection. And you could take this function, which now evaluates on demand, and have it instead return an object of a class which contains a pre-computed value. It would be a very, very simple thing to change, but it would completely change the runtime characteristics. So instead of doing a fold over the events whenever it is called, you would create an object. The object would subscribe to the events, subscribe to the store, and would just give you the pre-computed value whenever you call the function. You just hand out that function which gives you the pre-computed value as a result. So it's very easy to change from like the on-demand version to any kind of pre-computation. It's a little bit more difficult, but not much. Okay, this was the full circle through the system. I have a corollary in addition to this, but I'm not sure if it's of interest to all of you. I find it quite interesting because it shows how you can do things different in functional languages, and the way the website or the web server part is done. This is of interest.
Yes.
It's not my idea. I mean, nothing was my idea, of course. The ideas are all around there, and it's actually heavily taken from closure library from Meetup, which does the same thing. We're talking about HTML templating without templates. And the way they do it in the Meetup library, which I've also tried to mimic in this project because I think it is following. Let's suppose we go into let's look at the view of the video. That's a good example. So this was the web page. Is it still running? It's not running. Maybe back at it. Yeah, this web page. It's obviously HTML, and it's delivered by a single function called logistics form. And if I go into this function, what it does, it delivers a list. Brackets or the angular brackets are implementation of lists in F#. And contained in the list is a depot view, an orders view, and a purchase order view. And this is exactly the three parts of the system. However, it does something else. It types the result into a function called page, which basically renders all of the web page structure, including the menu on the outside. And since this is maybe the most interesting part, I'll just go into the page function. This is again a function. And what it does is again renders a list. It renders a list with the page header, which takes the title of the web page as an argument, which just gives the HTML. Sorry, not the HTML header, which gives the header here. It calls a function called navigation, which renders the menu. And it calls a function called page content, which renders the content. But what the content is, I actually gave in as a parameter. Okay, so if I go back to the report, which was here, well, this is actually the content of the content parameter. So what's inside the content parameter? And I can go a little bit deeper. If I go into the page header, then I find that it calls a function called h1 and provides an argument, or provides a title as an argument. And if I continue, h1 calls a function called h, is parameter 1, which is just above. And this calls a function called tag, provides the string h1 as a tag, and gives again the content as a variable, and this tag, I suppose you can imagine what it does is absolute. It basically constructs an h tag. Now the interesting thing, why I really like this a lot by now, is that you have that you can divide the rendering of the HTML in three different levels. The outside level, which is this module HTML, which is basically a library, essentially encapsulates the HTML language. The second level is in this case called layout, and it defines how this particular website should be rendered in terms of HTML. Meaning that whenever I want to render a section title, I'm going to render the content as an HTML H3 tag as a content. Whenever I want to render the data table, which has rows, I'm going to wrap the individual rows into TR tags, and then wrap the whole thing into a table tag. Now this is obviously the most trivial design in terms of HTML. Right? It's only the basic HTML structure, but it would be very trivial to say that, for example, a data table always has like certain CSS attributes. That a data table always has a caption in the footer below it. And the third level is the application level, which uses the layout, which we have, for example, what was the same at the start. And the thing one should look out for is that those three levels are never ever mixed. Okay, so from the application level, I must not ever directly put HTML tags inside. I only call functions which are defined either on the same level or on the layout level. This means that I can have a very concise layout model or layout definition which I can change at any time when the web page changes completely. Because I always only say, like, where's the table? Let's look for a table for a moment. It's a nice one. Sorry. This is a nice one. For example, the purchase order view, which is part of the structure I just showed you. It essentially takes, it has a section title, and then it takes all the orders. This is just the result of calling a read line, which we have seen before, and wraps them into whatever this function provides as a result, and then calls the data table function of the variable. Now the details are formatted by the function which is just above, which again takes the different parts from the read model, and then in this case creates columns. One is the current state of the order, then is the name of the product, the name of the supplier, the quantity, and whatever the settler was. And formats this in a data row in table, whatever data row means in context of the current layout. So this is highly composable, and you completely isolate not only the markup in terms of the CSS information structure, actually isolates the complete HTML generation from the system. So this is like what the templating languages are for in other systems. The nice thing about it is that it guarantees you that you can do a consistent layout, and it guarantees that you don't have to avoid repeating yourself when you create layout. Because whenever you do something twice, when you write the layout part, you think, okay, there seems to be a concept. For example, I have H2 several times, and it's always on top of something else. Hey, that's a section title, so let's introduce the function section title. So whenever I need to do this, I call the function section title. That's a basic idea. So it's highly composable, of course, because you just make small functions which do small parts of it, and it's a very simple, also it's very not simple. It's a very programmer-friendly way of coming up with the structure of a website, because you can actually start out from your business concerns. Because I know I want to do a view of purchase orders, and this means I have to somehow create a section to view them, and then I have to worry about the individual orders. But what do I do with the orders? I lay out them by making a function purchase order detail view. And then it goes down the levels until I finally arrive at the HTML. To me, it works very nicely because you don't start with the layout and then you somehow fit the stuff in the end. You start out with the stuff and then you think about how can I present this in a good way.
You should think instead of layout, you should call it components, because that's what other.
Yeah, that's right. It's probably better. You're right. And yes, I've used this now in 2 small projects by now, and I'm really, really happy with this. Of course, you can't get a web designer to do this, but actually, but it's not that bad because actually it works really great as a web designer, at least with a web designer which does HTML, not just PowerPoint, sorry, not just Photoshop. Because what the web designers usually do is the web designers come up with example components. And the web designer gives you one example for every different use case there is. And you can directly put them into functions and repeat or keep on using them. Whereas with a classical templating approach, you would at some point start to copy the HTML of the template around. That's small. That's the one for Tom because we discussed about this.
I think you explained it better this time than last time, because last time I didn't see the value in it.
Yeah.
Also, I'm sober now.
Actually, I didn't explain it last time. It was Martin trying to explain it.
Oh, yes,
This was.
Let's blame Martin.
The difference is by now I have a lot more experience in using this. But from the onset, this was earlier. Also, I couldn't put it into words. It's like you have the feeling that it's a good thing, but you can't really put it in words if you haven't done it. So now I've used it, and it's actually quite good. And this is really, for this F sharp, it's great. It's really great. Yeah. But my idea, the idea comes from the GitHub library of Clojure, where they do exactly the same thing for exactly the same.
Do you know if it exists in other languages?
I don't know. I've seen an approach like this for C# I think, a couple of days ago on some tweet or.
I've seen it as well. I've seen it in Germany previous time.
And C#. Yeah, so actually, I've been working on a C# version of this, but actually I prefer C# by far because it's just natural.
I have another question.
Yeah.
You use the types and casting, but usually why don't you use unions of types? So you could have just for serialization.
Good question. Well, in principle, you would have at least 4 different things you could use. So the question was for the events and for the commands, whether it's why it's records or types in general and not discriminated unions. I don't really know, actually, in this case. I mean, this was for demonstration purposes, and I tried to come up with a way of doing that which would serialize nicely to JSON. I have found that serialization coming from F# is really a nuisance. That's one of the parts which is not as nice. If I were to do this in production, I would use regular .NET structs in F#, probably, because they serialize best and are immutable. Or, alternatively, use any other structure from F#, which would probably use unions in the first place, because you can match on unions nicer, and you don't have to use reflection as much. But they use reflection too. It's basically the most useful thing. But at least the syntax reads nicer. And then generate serializers individually.
Because now you lose the advantage of, for example, when you're missing an event handler for a certain event, or otherwise you get a completion error.
Well, but that's, I mean, you can also, no, it's not really true, but even the pattern matching on types forces you to do the others, I think, once or otherwise. But I don't really know. I mean, I don't have a good answer which to prefer. All kinds of data structures in F# have weak points. So the records, they're quite difficult to use because you always have to specify the type within the parameters, because otherwise F# mixes up the different records types if it's not unique. Classes are mutable. I don't see a reason to use normal classes. Structs, I like structs, and in C# I only use structs, so they come naturally to me, and maybe I would use unions if I have more experience with doing better. I don't really know. Yeah, this is one of the things I noticed that, which are not nice in F#. This is maybe just, it's now specific to F#, but I found that very often I would actually need to do a thing like this. I would need to get like the GUID part of the ID, so the real GUID, out of the strongly typed identifier. And I would really, really love to have either something like the Scala
dynamic or something.
No. Not aspects, what's the name in Scala? If you implement something on an object later on, trace. I'd have loved to have something like the Scala trace, so I can define the GUID property once and have this implemented by all of them instead of having it implemented by hand. Or would it have loved to have macros in F#? So what I really did for the project, and this was the last thing on and close, is to use code generation. This is one of the things I noticed, that the more I work with function languages, especially Disclosure, the more I'm missing macros, so the more I'm using code generation. If you look at this is why I didn't show it initially. If you look at the events in here, so here are the events. So this is one event, they are records, but they need to override the toString function to give me a nice output for the log. And they also need to
you have a separate
construction.
construction.
I have a construction method in order to make it a little bit nicer and more readable. You have the construction, and this is, I mean, basically this is always the same.
That's something you can avoid if you just use type, then you
yeah, it's true.
leave
I don't need, but I wanted to avoid classes because I feel this is maybe a prejudice, but I feel uneasy using classes for immutable structures because in C# it's always not the best way because they are never really immutable. So I avoided classes later. But actually, as I've been working on this project, I've been thinking about changing this, but I just didn't change it. But the point is, it's always the same. No matter if it's classes or something else, it's always the same. So what I did for this project was something else. If you look up here, there's a common warning: don't modify this file because it's generated. And what I actually do is I take the specification file showed earlier. This was not for this group, but this was for demoing for the talk on code generation. And for example, if I change this event from supplier account open, so a supplier account was opened, and I have a small code generator which I can run in the F# interactive mode immediately. So immediately executes, and if I go back to the events, and reload this, now this is called, now it's called supplier account was open, so it changes. So what I basically do is I pass a markup file, and for the section called business events, I take the structure and transform this code generation into the F# code. Because this is something you write once, and you can always add an event by just writing a few lines of markup code and then you have the event.
If you go back to the other view, you could actually do, for example, for a supplier account was opened. You could say equals, and then supplier account was opened of supplier ID, supplier designation string.
Yes, but it still doesn't save me from repeatedly having to write the same stuff. It's like
then you don't need the event supplier account was opened.
No, this method could be super close, but I still need to worry about the two-string part. Or with the IDs, this was where I was coming from, I would still need to worry about the ID member to unpack this strongly typed ID, because there is no way to do it other than F#.
That's because
that's because it's a union. But
no, you should use product ID, which is cast as a GUID. You should type product ID equals product ID of GUID. If you just
Take over the keyboard.
but that's what it is.
No, type product ID on top of that. Just type product ID equals product ID of GUID. Product ID.
Yeah, but it's the same thing. I don't see a difference.
Now that's a constructor as well now, product if. So if you call product if with a GUID as a parameter, it constructs a product ID.
Yes, I know, but I can't get the ID out without doing pattern matching.
Or you can just add ID colon in front of it. That's new since F#, no, in front of the GUID. You can have named ID.
Yeah, you can do this now.
Okay. Like this, or it's the other way around, I don't know. Yeah, something like that.
It should be this way around.
Yeah.
Okay.
So now you don't need all the other stuff to assign it and to. But it's new in F#.
You know what's the nice thing is? I can now take this idea, go to my code generator.
But you don't need a code generator if you don't use.
Well, but if without the code generator, I would have to change it manually.
No, you change it in one place because you compose all your types together. No, never mind. Let's just.
But I'm still missing macros.
Yeah, never.
We should probably
Call it.
Yeah. Okay, so what did I do? I tried to do a gross overview of exemplary combination of event sourcing and CQRS, and the aim was basically to bring out the few concepts, namely the reusing of projections and the separation of the definition of the projection and the execution of the projection in terms of really projecting and sometimes event, and how to introduce this in a CQRS system. As you noticed, I very soon got away from trying to live code the complete application because it was mainly meant as an introduction to CQRS and event sourcing, and since the show of hands was quite clear in that regard, I tried to rather pick out the interesting parts and show them. I realized that it's not, it's difficult to get like a complete picture from this. This was also not the aim, but if you're interested, you can have a look at the source code and play with it. And there's a lot to be done with it because there's nearly no functionality in it, and you can have a lot of ideas on how to put in business rules, like for example, automatic stocking, just to name a few ideas. And maybe Tom can overhaul the F# version. It's more. So I think there will be the possibility to join.
Yeah. So well, first of all, thank you, Philip. For,
Thank you.
and thanks to our agency for hosting us and paying for the prize.